Hello and welcome to R&D Mathematics. And today we are going to talk about determinants. Determinants. The 2 by 2 case today. And yeah, let's start with the 2 by 2 matrix. Let's call this ABCD. In this case, we define something known as determinant of M to be AD minus BC. So for an example, so AD means, multiplication of the main diagonal minus the other diagonal. Again, this definition only for 2 by 2, right? So later we'll generalize this, but let's see some examples. Let's say 4, 2, 1, 3. In this case, let's call this guy A, and the determinant of A is 4 into 3, the main diagonal, minus 1 into 2, right? So 12 minus 2, which is 10. And how about this example? 1, negative 1, 2. So determinant of P, 4 into 2, 8, minus, that minus is in the definition, and again you have minus. So minus 1 into 1, so 8 plus 1, 8, 9, right? So simple as that, that is the determinant. Now, few things to note. There are other notations. So few other notations. Determinant of A, sometimes we denote it like this, like the absolute value, but we have to be careful because determinant can be negative. Let me give you a quick example. For example, let's say C, how about negative 1, 2, 3, 10. In this case, if you find determinant of C, it's going to be negative 1 into 10, negative 10, minus 6, so negative 16. So determinant can be negative even though we don't denote it by something like this, similar to absolute value bars. And sometimes determinant of A using this delta notation. So these are the famous notations. And also, like, let's take this example B. 4, 1. If I draw two bars around these numbers, that means I'm talking about the determinant. If I do this, that means that's the matrix. Okay, I think those things should be clear. And with the standard notation, it's like this. So A11, A12, A21, A22. So the determinant of A11, A22 minus A21, A12. So that's with the standard notation. And also remember, so determinant of A, which is same as this, which is same as this, is a number. It can be a positive, negative, fraction, whatever, but it's a number. It's not a matrix, right? Because when you do some see, even though this looks like this, close to being a matrix, this is 8 into 5, 40 minus 3, 37. See, it is a number. Okay, I think that should be clear. Now, let's see some examples. Before that, if determinant of M is 0, we call the matrix M is singular. And if not, well, non-singular. We'll talk more about this when we are doing inverse of a matrix. So for the time being, just the definition. Now let's see an example. Given that A is singular, find little a. So A, 1 plus A, 3 minus A, a plus 2, 1 minus a. Now, a is singular. That means determinant of a is 0, right? First find the determinant. So this guy, a plus a into, sorry, 1 plus a into 1 minus a minus 3 minus a into a plus 2. That is 0. So this one, difference between 2 squared, that is 1 minus a squared, minus, let me put this parentheses. And if I take a minus sign out, this becomes a minus 3 and this becomes plus a plus 2 is 0. So 1 minus a squared plus, I have a squared minus 3a plus 2a, so minus a minus 6. And this will cancel, so ultimate result is minus 5 minus a. So a is going to be negative 5, right? Okay, see, even though you can use a calculator to find the determinants, you cannot do this kind of a problem by using a calculator easily. So let's do one more problem for this video. How about this? M 1 2 3 4 and negative 1 2 5 8. So let's see what the determinant of M. So part A, let's say find the determinant of M. Part B, find the determinant of N. Part C, find the matrix product Mn. And part D, find the matrix product Nm. This is a special because both of them are 2 by 2, so you can find Mn and Mn. They may not, in general, matrix multiplication is not commutative. We talked about this, and if you cannot remember, please go back and watch matrix multiplication video. Part E, find determinant of Mn. Part F, find determinant of Nm. And part G, like let's say any idea, looking at these results, any conclusions. Okay, I suggest you to pause the video and solve these things first. Okay, assuming you have done that, let's do it quickly. M, determinant of M, 4 into 1, 4 minus 6, so minus 2. Determinant of N, negative 8 minus 10, so negative 18. Matrix Mn. So you had to write the matrix. Now they are in the order, so let me do it. So this row into this column, remember that's how we, so let me do that. 1 and negative 1 plus 5, so negative 1 plus 10, so 9. Then 2 plus 16, 18. Then negative 3 plus 20, so 17. Then 6 plus 32, so 38. And let's do part D because you can find determinant here. So 9 into 38 minus 18 into 17. So 9 into 8, 72, 7 left, 9 into 3, 27, and that's 7, 34, minus, okay, 18 and 17, so you are getting 42, basically it's 42 minus 6, so 36, right? That's the determinant of Mn. Now Nm, so it's advisable to write them in the way that it appears in the matrix multiplication, otherwise it's hard to do it in your head. So this is M, this is N, so Mn, let's see, negative 1, 6, so 5, negative 2, 8, so 6, 5, and 24, so 29, 10 and 32, so 42, right? And now let's address part F. So the determinant of n, wait a minute, here I'm making a mistake. Determinant of nm, this guy is n, this guy is m, so nm. So 5 into 42 minus 6 into 29. Minus 6 into 9, 54. Now let's see. 210 minus 76. So 6, 36. Is this a coincidence? Now in general, okay, now let me. So we are talking about, when we talk about determinants, right? Determinants. We are in the realm of square matrices. So in general, you know AB is not same as BA, but you take the determinant, because that's the number, that's going to be the same. Not just that, let me go back. Look at these numbers. So determinant of mn and nm happen to be 36, but how about determinant of m and n? Look at these numbers. If I multiply these two numbers, what am I getting? Negative, negative, positive, 2 into 18, 36. So a determinant of AB is determinant of A times determinant of B. That happens, and we'll prove that later. Okay guys, that's it for today, and thank you.